Welcome to the how-to video for Lewis structures. So first, if we just think about different chemical bonds and how electrons are either shared or transferred between atoms and chemical bonds. And so first we really need to think about the valence electrons. And when we talk about valence electrons, these are the electrons that are going to be involved in bonding. They're the outer shell electrons. So when we look at something like boron, right, we know boron has an atomic number of 5. And that really means that it has 5 electrons and 5 protons. 2 electrons are here in the n equals 1 electron shell, and then we have 3 out here in the n equals 2 electron shell. Well, our outermost electrons are our valence electrons. So those 3 electrons in the outermost shell are the ones that are going to actually participate in bonding. So a guy named G.N. Lewis came up with a way to show these valence electrons in a much simpler way, where basically we write the element's chemical symbol, and then we put dots around it for each valence electron. And so if we look at sulfur, okay, sulfur, if you were to write out the electron configuration, the condensed version, you would see that you have 3s2, 3p4, which tells you have 6 valence electrons for sulfur. So the way that we draw this is we write the chemical symbol, and then we surround that by the electrons, showing those are the valence electrons. Now we usually try to spread these out as much as possible, where 2 dots go on each side of the chemical symbol. Carbon, on the other hand, has 4 valence electrons, 2 in the 2s2, 2, 2p2. And so the Lewis structure for it would be carbon with the 4 electrons around it. Now there's actually a simpler way to identify the valence electrons, because if we look at sulfur on the periodic table, and we said, okay, well we know sulfur is right here, well it's in group 6A. Group 6A means that it has 6 valence electrons. When we look at carbon, carbon is over here in group 4A, and guess what? It also has 4 valence electrons. And so by looking at the group number, we can then determine how many valence electrons there are. So really, group 1A has 1 valence electron, 2A has 2, 3 has 3, 4A has 4, and so forth. The transition elements are a little bit different, and we're going to talk about that in just a second. So everything in between in these transition elements in groups B are actually exceptions to the octet rule because they. So the thing to remember when we look at what we call the octet rule is atoms want to either gain, they want to lose, or they're going to share electrons until they're surrounded by 8 valence electrons. That's what all these atoms are trying to do, get 8 valence electrons in their outermost shell. And so an octet of electrons is always going to consist of a full s and a full p subshell. Means that you have ns2, np6. Now transition metals, which are in that middle part, are the exception to the octet rule, multiple charges. That completes the how-to for Lewis structures.